Great. I'm going to leave your slides up for a second because we have some questions. Duncan wants to know, do you prefer Tokyo over async STD?
I haven't used them too much, so I wouldn't say I have a huge preference, but Tokyo seems to have most of the momentum behind it, and there's a kind of like a whole ecosystem built around it, so I tend to just use it purely because like I feel like the most popular out of the two. Yeah.
Okay. And the name's more easier to pronounce as well.
Yeah.
And then I have a question. I wanted to know, what's the debug environment like? I'm just going to take, do you want to show us more slides or show us more anything? Because I can take your slides off.
Yeah, you can take them off. You can take them off.
Okay, cool. So I wanted to know what the debug environment was and if there were tools or testing tools to help either debug or test these async things, because they're typically tricky to debug and test.
Yeah, so as far as I know, not that much, but there is a lot of work going on with that at the moment. And so they have this idea, like Tokyo is working on this thing called like Tokyo Console, which is kind of like top for like tasks that you're running. And so that'll kind of like output like, what tasks are in progress, how long they've been taking to run, all that stuff. And so that's kind of like a diagnostic tooling that I know is busy being made. But in general, I don't know too much about that, if it is a huge thing yet or not. Yeah.
Duncan's on stage with us. So, yeah, I was just hoping that there would be like some help to stop you from, if you like, if you make a deadlock or you make,
yeah. So like with Tokyo, for instance, they have implemented this idea that like each task sort of like has a budget. So you can't actually spawn a task and it will just block everything else. If it's been running for too long, they'll just like take it off the CPU and run something else, which is just kind of like an optimization they've decided to make, which I guess makes sense.
Yeah, it makes it much safer. And then, I had another question. In Kotlin, you've got this concept with the coroutines, and I think in Go as well, where you're not actually managing the threads yourself. This runtime that you were speaking about actually does the threading. But in Kotlin, you can tell it, okay, I wanted to use like the environment or the scope, which has 1 thread or 2 threads or 3 threads or whatever. You can control that. Do you have that kind of control in your runtime, or?
I'm not sure about the number of threads. I feel like yes, though I'm not entirely sure. But you can also choose. I know that you can choose between single and multi-threaded executors. I'm not sure if you can specify like the number of threads or environments, but I feel like that is definitely possible. Like it should.
Yeah, because I think typically what you would use that for is like, say you had something that's very IO, you could have one of these executors that work just for IO stuff. And if you had something else that needed to do a lot of computations, you could have another one. And then the two wouldn't fight about the about the resources. Let's just see if there's any more questions. I don't see. Lots of people are saying great talks, great talks. Let me put those on the stage for you so you can see those. And then while you read those, I have some questions that I want to ask. So I'm just getting some good feedback for you. Okay.
Cool.
Ewald says, out of interest, has using Rust changed your general approach to software development in any way?
So for me, yes. And mainly, I guess for me, the biggest thing has been on error handling. So Rust has this idea, and I think it's standard in like all the ML programming languages, that you have like an option type or the result type, basically. And so it encodes in the type system that like something can fail automatically. Like if you have a result type, you get either the type encodes like fail or some type like a integer or whatever that you get back. And then the option type will be either none or some value. But because they've got different names, like an option is basically a none or something, you have to handle the case where you get like none out. And so for me, that's kind of like translated into being thoughtful about like how I write, let's say like Python, where in Python you can return none or an integer or a dictionary or whatever at different points in your program, and like someone just has to cater for it. And so for me, it's being like way more thoughtful about like if my function can fail or will return a none, like how do I communicate that properly, or do I return like a tuple or something that has like whatever. And so that's basically been, I guess, like the most biggest change for me. Outside of that, there are just some stuff like I guess you learn a lot about like Rust doesn't hide too much from you, so you'll start learning about like all the low level stuff, and that does kind of like frame the way you think about things. But I mean, you don't have to think about it too much.
And you, Duncan, have you got any changes that you noticed in your coding behavior from using Rust?
So yeah, I also think like using Rust, I come primarily from a dynamically typed language background, and everything like that, and I came to sort of appreciate a strongly typed language, and sort of also I work every day with TypeScript, and I know that's a layer over JavaScript, and at the end of the day you're dealing with sort of dynamic typing in the runtime. But I think some of my approaches in TypeScript have changed just from using Rust, is also around making sure that you check everything and your type safety and things like that. But I want to say, like, if I'm just using Rust, it's sort of like the one major thing that I love about it is I've never had such helpful compiler errors in my life.
Yeah.
It's almost like compiler-driven development.
Oh, that's super interesting. So if you say it's got strong typing, does it have a nullable? Have you got this concept of nullable or non-nullable types? Because like Kotlin, you can have a string or a nullable string.
So there's no... Yeah, Duncan, you can go.
No, go for it.
Oh yeah, saying so in Rust that would be like an option type, and an option would be like an option encodes that this thing can be a string or none, but then you have to handle the case where it's none. So that's basically how it's encoded in Rust. Yeah.
Oh, okay, so it's like a none. Okay, so my next question to both of you is, what's your favorite feature in Rust that you don't see in other languages? And on the flip side, what's a really nice feature in another language that you like, but that you wish that they had in Rust? Let's see, Duncan can go first.
That's so interesting.
Me going first. Okay, I'm actually going to turn the question around. I'll first say something that I kind of miss in Rust, but have sort of not... like I've not missed it that much recently, is around actual optional parameters. Like, so it's like I've gotten quite used to the builder pattern in a lot of my projects, where, like we saw in Dino as well, like where you build the extension out, use methods to tack onto that struct, and and then end it with a build. So I still do use a lot of optional parameters in TypeScript and that kind of thing. So when I go to Rust, it's sometimes a bit of a, but there's, like, I don't miss it as much. I feel like, idiomatic Rust gets around it okay.
So are you saying that's where if you've got a function with 4 parameters that you only need to put in 2 of the 4? Is that what you mean by optional parameters?
Yeah.
Okay. So in Kotlin, you can make default values. So that would make them look like optional. I mean, I'm not sure what happens in JavaScript, but then in Rust, you're saying you can't do that. Do you have named parameters in Rust?
So is it like labeled parameters?
Yeah. So you can say this parameter, and give them the name so that you can get them out of order if you need to.
No.
Oh, I think I'd missed that. I'd missed that. And you, Senyo, what features do you miss and what features do you love?
So the optional ones is a big one for me, and I think also like having default values. Like sometimes you just want to be like, the default value is 5, just make it 5, but there's no such thing. And so, but it doesn't feel that bad. But I guess like it's definitely something I miss. And then my favorite feature has to be pattern matching. I miss that like all the time when I'm writing Python. It's just so convenient. And so yeah, that's definitely the biggest one.
Did you say your favorite feature, Duncan?
Oh no, I didn't. Yeah, so there's quite a few actually. I think of one.
You can have 2 or 3. Okay, you can have 3.
No. Yeah, I'd say I also really like the pattern matching, to be honest. It's extremely powerful, like things that you thought it might not be able to do, like sort of surprises me every day.
For sure.
Yeah, so it's really cool.
Okay, so my next question is, Rust is sort of touted as like the C replacement. So what areas, where do you think we'll see people using Rust?
So Rust at the moment is basically used in like anywhere where you need, I guess like anywhere where you need C or C++ in the sense that like you want very high performing software. So you can imagine things like databases, in-memory databases, like TCP stacks, like all your networking stuff, like that kind of spaces where it's primed for. But I have been seeing a lot of people like using it for standard web development, or like cloud native web development. And a big reason why people enjoy it in that space is because it doesn't have a runtime. It has very predictable performance. So like if you read enough around, you'll often find that companies at some certain scale, they'll start having problems with their garbage collector, and so like it'll start collecting garbage, and then your latencies will skyrocket for like that period of time. And so with Rust, you don't have that, so you can pretty much say like my latency is constant all the time. Obviously, there's definitely probably like exceptions to that rule, but that's the one case where people are kind of like justifying it for using like in standard web dev. So yeah.
I can also mention somewhere where I've seen it being used more and more is, okay, coming from Luna, more exposed to a lot of the open source Bitcoin projects. So if we just look at Bitcoin Core, like that started in 2008, roundabout, and it was in C++. It's still in C++ today. And but a lot of these auxiliary projects, starting out maybe in the last 2 or 3 years, have actually started in Rust, and the like number of contributors that join those projects, it's also like systems level stuff, and distributed systems, things like some lightning kits, things like that. I think the barrier to entry is much lower for systems language like Rust compared to C++, and everything seems familiar. At least that's how I experienced it when switching between projects and things. And yeah.
Okay, I see there's another question in chat. So chat wants to know, and Nelly wants to know, pattern matching as in regex. So I think maybe give us an example of the kind of pattern matching that you would do in Rust.
Sure. So it's more, I guess, how do you even describe pattern matching? It's more that you match on like, I think in this case, it'd be like structural pattern matching. So you'd match on, let's say you have a tuple that returns like an X and Y coordinate or something. Then you can like destructure them by creating it like, let me see if I can pull up an example. That would just be way easier.
Okay.
Yeah.
Let's see if I can. So while you're thinking about that, while you're pulling up an example, I'll put your screen up and just see if I've got another question. So you were saying about that there's no garbage collector. Yes. But now I was thinking about that, right? So can you do like memory allocations?
Yeah, of course. No, definitely.
And then then you have to remember to free, or how are you doing that?
So that's like part of Rust's types, like not in type system in terms of like the way it's implemented. So Rust uses, I think, something called reference counting, basically.
Oh, okay.
And so basically, like when it drops out of scope, it'll just free the memory for you. And so
okay. So it's got like a reference counter thing that's happening in the background. So I'm assuming that's at compile time, right? So it wouldn't be at runtime.
Yeah, as far as I know, mostly. As far as I know, yeah. But there is technically a runtime. It's just like so lightweight that it's effectively not a runtime.
Okay.
Let me see if I can share my screen here. Let's see.
Okay, I'm going to hide Anila's question.
Cool.
Fritz says it's a switch statement on steroids.
Effectively,
Okay.
that is true. So you can see. Can you see is my screen on?
Wait, I'm going to add your screen.
Okay, cool.
Yeah.
So
yeah, you can see him.
Cool. So you can see here you have this like let x equal 1, and then you can match on x in this case. So I guess you get like there's something called structural pattern matching, and then I don't know what the other one is, but this doesn't feel like structural pattern matching. And so in this case, this would just match on like what is contained in this variable. So this would get printed in this case. And if you change this to 2, this would get printed. And then if it was like 5, then this would evaluate. This is like a wild card for like if it doesn't match any of these. Do this.
I see. So it's, I mean, if you had to code that normally, you would have like if and else statements, right?
Yeah.
You'd have like a whole nested if else statements. Okay, yeah. So Kotlin has a when statement that does something similar.
Okay, cool.
Okay, cool.
And then you also get these kinds of pattern matching. So this is like a structural pattern match where you have like x equals sum 5, where if just for the sake of saying sum is like sum struct, if you wanted to say that. And so when you match on x, it will compare these branches. So here in this first one, sum 50 doesn't match because this is sum 5, but this sum y will actually match. And the reason why is because this is basically binds to this variable in here. And so what will end up happening is this will run and print out, this will run here and say matched y something.
Okay.
And so you can also kind of think about this like if you had to destructure a variable, like you could say like let sum y, like let this equal sum 5, and then y would automatically equal 5. That's basically like a type of pattern matching. And so yeah, it's just goes to this.
Sure, it's amazing. Yeah, you can see you can do actually pretty cool stuff. I can see that you'd miss that if you don't have it right, because you'd have to write.
Yeah, of course.
Yeah,
a lot of it. So like here's a good one on the like pattern matching. So you've got this point which has like an x is 0 and y equals 7, and then you can match on that like variable, I guess, where here you've got x is an a and y is equal to some b, and this a and b will bind to 0 and 7 respectively. So these things, now a is equal to 0 and b is equal to 7 because of the way this thing is destructured. So that's also a type of pattern match. So that's basically one of the things like, I miss it all the time.
Okay.
Match like beautiful reference things and do some funky stuff with it too.
Yeah.
Interesting.
Okay, so then my next question is, what's the IDE environment? What's the dev environment like? What do you use?
I use VS Code, and there's like a LSP called Rust Analyzer. So I use that. I think there's also Rust IntelliJ or something. I don't know.
Is there an IntelliJ version for Rust?
Yeah, I think there's Yeah.
Okay.
Yeah.
Cool. Okay, but I guess if people that come from the web world also like VS Code, and I think so VS Code. So then I'm assuming you can do like breakpoints and debug inside there. It'll all be integrated.
Mm-hmm.
And then the last question is, will your slides be available, and or what are your favorite learning resources for learning Rust if someone wants to learn Rust?
Duncan, you can go first.
Okay, cool. I will make my slides available. I just they're not prepped. I need to just convert to PDF or something. And then also use VS Code with Rust Analyzer. It's really good. And then the last part of that question, what was it again, Maia?
It's the one about what are your favorite learning resources? If I want to start learning Rust, where should I start? What are some good links? We'll put the links in the description, and we'll put the links in our tweets as well.
Yeah, so you definitely should start with the Rust book. It's just so good.
100%.
Yeah.
The Rust book, okay.
Yeah, I'll show you if you just type it, but maybe let me just share. Can you share it, Maia?
Yes, I'm looking to see. Did you put your screen up? You sharing your screen?
No. I just shared the link.
Oh, you shared the link to me?
Yeah, to you.
Okay. All right, let me see if I can. share. Okay, let's see if I can share. We have the technology. I can share. Oh no, do we want to share the screen for the Rust book, or are we just going to share the?
Let me share my screen actually. Then you can also.
Okay, I'll put that in the comments as well. I'll put that link in the comments.
This is not right. So I clicked the wrong things. Let's just share.
My keyboard's not working. My remote keyboard's not working from the load shedding. Okay, so that's the link.
Let me just make Docker.
Okay, Docker, add to stream. Okay.
Everyone's eyes. Okay, yeah. So this is the Rust book. If you just type Rust book into Google, it should also get you here. It's doc.rust-lang.org/book, and this is really, it takes you from real basics, installation, programming and guessing game, really getting to know the Rust primitives and things. And I think you end off like implementing a web server, right? Something like that. But yeah, it's sort of nice. It's a great reference. Like I even go back to this, to check things that I might have forgotten, or definitely. And then I think the sort of auxiliary to this is Rust by example. So that's always quite nice if you're looking for a specific thing, like a specific idiomatic example of something. And then I can also chat about more intermediate level stuff, because I feel like that's where a lot of people maybe they seem to drop off, and they feel like, I can't find any content. And I think that's where streams really become helpful. There's a lot of streamers that maybe I can share the links to on Twitter.
On Twitch, you mean? Twitch streamers?
Yeah, Twitch streamers. And then also there's a recent book, Rust Forestations, by one of these Twitch streamers, and it's sort of aimed at the intermediate to more advanced Rust. So I think, that you'll probably start, seeing less resources when you become more intermediate, and you've got to dig a bit deeper and maybe read source code, that kind of thing. I don't know, if you've got any other resources.
No, not particularly. There's a person named John Jengist, I'm not too sure, who does, he's the one that wrote Rust for Rustations. Yeah. So he's pretty good. But otherwise the book, that's how I started. I'd highly recommend it. It's pretty much.
Okay, so for the audience, we're gonna put all of the links. We'll collect the links of the slides and the resources and put them in there. I don't know if anybody else has any more questions. You guys don't have questions for each other. And with that, I'm going to say thank you so much. This has been super interesting. Thank you very much for prepping and for doing a talk for us. And also, again, a little plug for Peach Payments, who is our sponsor. So thank you, Peach Payments. Let's see if there's anything in chat. Borrow checker. Can you guys comment? Okay, we're going to have this one. All right. No, you can't go yet. You have to talk about the borrow checker. Go.
I feel like I haven't encountered the borrow checker. No, I have. No, I actually haven't. I don't know. It gets to a point where it doesn't really bother you that much.
What is it? I don't even know what it is.
So the borrow checker is basically it checks how many kind of like references or aliases you have to a certain variable, because Rust has a certain set of rules. So you can only hold one mutable reference to a variable at a time, or any number of immutable references. And basically the borrow checker makes sure that rule is enforced. And so what people will often do is have like mutable variables and pass them around, and then the borrow checker will say, listen, you can't actually do this, you can't borrow this thing as mutable. And so that tends to happen a lot. And then there's also, it has like interesting move semantics and stuff like that. So depending on that, you'll always get these errors that crop up and say you can't use this variable here because you moved it somewhere earlier.
Okay, so it's like the Rust Grinch. That like if you're being too loose with all your variables. But I mean, it makes sense. It's mutable variables, right? That could be like a concurrency. There could be a concurrency issue around mutable variables. So it's obviously best to keep things immutable as far as possible, and then just make them immutable when you need to.
Exactly. So that's pretty much it.
Yeah, it's all at compile time as well. So you're trying to compile your program, and then the borrow checker shouts at you, and it's called fighting with the borrow checker. I must say, like, the errors have improved significantly, and the amount of context that the compiler has or like shows you, and it's like it makes suggestions. It's just amazing. Like, I've got to like praise the compiler again. But yeah, it's like, I think when I started as well, it was I mean, I've been on and off with Rust, but I've been playing around for like a few years, and maybe some of the errors weren't as helpful, and you have to dig around and try and find out. And I think those were the days of probably the worst fighting with the borrow checker. Whereas once you get used to it as well, obviously you will encounter it here and there when you're using more complex stuff, but your brain sort of gets into that thinking of how a Rust borrow checker works, and then you get onto lifetimes, and you sort of all over again.
Oh no! Now you have to tell me what that is, because I don't know what that is either.
So lifetimes are basically Rust basically computes how long certain variables will live for, and in some cases it can't automatically figure that out, so you have to specify it yourself. Normally, like when you're holding like a reference to something inside like a struct, basically. And so, when that happens, then it's like a very difficult thing to wrap your head around, and how Rust enforces those rules and everything like that. So as soon as you start hitting lifetime and specifying them yourself, it becomes like pretty difficult to reason about them. Initially, it definitely gets easier, but I'm still at the it's still difficult to think about that stage.
So I guess by the time you know how to reason about it, then that's when Rust has changed the way you code, right? Because you're just thinking differently, and so all of a sudden it becomes easy.
Possibly, yeah.
Okay, chat. I think, sorry, Duncan, go.
Sorry, Maia. I think one of the ways people in the beginning try and get around, too much lifetime stuff is they'll clone a lot.
Yeah.
It's like, obviously you got that extra cost of doing that, and once you get more advanced, and lifetimes are also introduced in the Rust book, so sort of maybe not in all its gore, but definitely I still refer back to it, because so it always feels like maybe that is one of the things that I would consider as the steep learning curve. Getting to the steep part of Rust is definitely lifetimes. Yeah.
Okay, so that's what our next talk's going to be about, right?
Hopefully we'll get there.
Okay, I think I'm going to let you go. Cool. I don't see any more chat questions. Chat people, this is your last chance to ask our fantastic guests questions. I don't see any.